Hello everybody, this is going to be a quick video that shows what to do if you're passing all the tests for the K-mer lab except for one. So I want you to imagine you've been working hard on this. You get the long concurrent map to work, test it with Java's map. We get the interarray, we'll go through all those, they work. We got the atomic interarray, so we can do it in parallel. And now we're testing our thread safe map we've made. And it's down here running this chromosome complete. It's trying to run the full Y chromosome, K equals 5. It's checking all of them, and all right, now we've like run out of memory. So let's click on this. See, we're trying to make a lot. We're making a whole array of it, so we've run out of memory there. If I look a little further down, you can sort of see the test where it's being created from. Well, there's the full app. That's not the most useful place. Let's sort of click on here, and we can find out, yeah. So this is where we're calling parse with this thing. Let's do a little more investigation here. So we're running out of memory. We're passing like so many different incantations of this K-mer counter thing with our thread safe map. Let's see, we're passing all the SARS-CoV-2 ones, the cholera, mitochondrion. I have a Y chromosome where I take a subset of it, so it's tiny. We're working there. And then we pass the complete test with this is a requested initial capacity passed along. That's false. Like that works. And then I tried just the exact same test, but with that true, and it fails. So let's sort of look into this. I created this set of tests just for you to try to make some sense of this. There's that bonus crazy extra perimeter. When we create this long concurrent map, somebody has, when we go do this, this guy is going to tell us what capacity we want to pass along to the thread safe map that you made. And in this case, I have incorrectly said, all right, we need an int. What's a good number that's sort of like how many keys I can sort of expect? Let's calculate sum of all K-mer. So that's sort of like n minus k plus 1 for each of the sequences. If I pass that along, and I actually use it, right? It's present, I'm going to use it, then it fails. If I just say ignore it in the test, it works. So like somehow that seems like a pretty good clue that something's going wrong, and that this n minus k plus 1 is pretty good for some cases, but not all of them. Right, so let's do a little bit of investigation here. I've got a little capacity demo I'm going to build. Here I have the Y chromosome complete. Read in, I've got it in all of its sequences, everything's good to go. Let's use the example from this test where K was 5. And I just want to sort of like, how many of them are there? Like how many of them are in this sequence, right? And just like I did in the thing, let's just do calculate sum of all K-mers. That'll give me n minus k plus 1 for each one for this Y chromosome. I'm going to grab the other one, which is sort of the other interesting number, which is the total possibilities. And that's K-mer tills, calculate possible K-mers of K. And if I this out, if I just print out like, all right, so K is, that's K, right? And let me just print out all this information. That's how many, and that's total possibilities. This is going to be 4 to the K, and this is going to be n minus k plus 1. Line them all up so that I can read it a little while here. So if I look at this, right, this gives you some sort of sense of what's going on. So like when K is 5, the Y chromosome is about 26 million long, right? And so how many total K-mers you're going to get is based on like how long that K is, right? And n is, but n is the dominant factor. And since K is only 5, like that's 4 to the 5th, that's 2 to the 10th, that's 1,000, right? So there's going to be a ton of duplicates. Like the most number that I could possibly hope for in this case is going to be like, these are how many K-mers there are. There's going to be so many duplicates because there can only be 1,024 possible values. Now, if I do K equals 23 here, right, this number is going to be huge. This is now 4 to the 23rd or 2 to the 46th, which is ginormous number. Like there's million, billion, I'm going to guess at 70 trillion, right? That's a very large number. I cannot make that number. So 4 minus k plus 1 is not the best case answer there, right? If I were to do this for, say, SARS, right? So, or SARS-CoV-2, if I do it here, right, that's a smaller version of a chromosome, right? Like, excuse me, that's a smaller piece of, well, it's now complementary DNA, but like that one, n minus k plus 1, like that looks like a more reasonable number. Like if I'm counting the 23 mers, I certainly do not want to allocate this much space. It's closer to this. There'll be some duplicates. I don't need exactly that many, but that's kind of a better initial capacity in this case, right? Whereas, you know, if I'm doing a larger thing now, the Y chromosome is the smallest of all of our chromosomes, but even it at 26 million, right? Like, oh, now 4 minus k, 4 to the k is doing better. So sort of task for you to figure out is, all right, so I want something that works well in both cases, right? And I want the smaller of the two. The rather straightforward problem I'll leave to you is, how do you take two numbers and figure out which one's the smaller of them? What I'll say as a one last final thing is, if I go back to this k is 23 situation, there's a reason why I had this return it as a long. This number is too big for an integer. And so if I do a bonus one, which is like the int version of this, you know, integer version, if I cast this guy, let me indent everybody. If I cast this guy to an int, that's going to be 0, because if I look at this, if I look at this number, 4 to the k is a binary string. If I say long.to binary string, this is what, for those of you who have not taken 361 or something like that, this is what 2 to the 46 looks like in binary. It's a 1 followed by 46 zeros in binary. What converting it to an int would do is take the bottom 32 numbers. Let's say that's bottom 32. And so it becomes 0. So if you're looking for the smaller one, you need to do it when it's a long. You don't want to do it, you don't want to compare 0 versus this number, because then you would choose 0. So with that, hopefully this will help you get through. Those of you who have hit this problem on the last of all the K-mer counting tests.